So this is the DSC TGA. It goes from approximately room temperature. It's really better starting at 50 degrees Celsius, but it goes up to 1500 degrees Celsius. This right here, this is the furnace. It moves back and forth. These are the sample beams right here. The sample goes on the forward beam and a reference goes on the back beam. As is necessary with DSC, there is a reference, an empty reference pan, that runs alongside the sample. This right here, this is the sample plate. This is where you place your crucibles that have your sample on it, that have your sample in it. And then these three fingers down underneath here are the auto samplers. Those grab the crucibles and place them onto the sample beams over there in order for them to run. So all you really need to do is place your sample here. There's no need to interact with the beams on your own. This screen right here shows what's going on with the TGA. We've got temperature right here in the top corner. You can see there's a little exclamation mark. That means that there is something preventing the machine from starting to run right now. So that's a good indicator that you should double check that everything's working. In this case, and what is most commonly the case when this is turned on, that means that the gases are not turned on. We have two gases that run to this, a nitrogen and an air. The nitrogen is always flowing no matter what. The nitrogen, at a minimum, flows over the electronics of the system to purge the entire system and put it under a just uniform atmosphere. It also, if you choose to, the nitrogen can flow over your sample, so you have an inert atmosphere over your sample. The other gas that we always have hooked up is air, just regular breathing air. The air turns on and off depending on whether you want it. If you don't have the nitrogen flowing over your sample, then the air is what will be flowing over your sample. So the nitrogen kind of has two jobs. One is always running over the instrument, and then its second job switches off with the air, where you can choose either nitrogen or air to run over your samples. If you need a gas other than nitrogen or air to run your sample in, please talk to staff and we'll help you get that set up. These are the tanks. These are against the back wall behind the TGA. This is the air tank here in front. This is the nitrogen tank here in back. For any compressed air canisters that you work with in the MCL, you do not want to touch the regulator. These are set up to run exactly how the machines need them with the correct pressures going out. To open and close the tanks, you just want to mess with the top, and we're going to rotate that to turn it on. So, in case you are unfamiliar with regulators, this right here, this side, is reading the pressure of the tank. Between 2,000 and 2,500, that's usually full. So you can see this is a pretty new tank. This is the output pressure right here. We're at about 20 psi, which is what the TGA requires. And then these little tubes go all the way over to the instrument and plug in the back. This back here is the nitrogen. You can see that the needle is down below 500. If you ever notice that the needle is below 500, please talk to the staff. We consider this tank empty or nearly empty, so we will order a new one in order to replace this one. But you can see we also have about 20 psi, pretty close to 20 psi coming out of the nitrogen tank as well. To double check that it's turned on, you can rotate the top. Again, do not touch this front part of the regulator. That's to be left alone. So when we get to the computer here, and this is before we've loaded any samples, before we've done anything with the instrument, we're going to open up the software. Trios is the name of the software. It's in this bottom corner. It's also on the main toolbar down here at the bottom, Trios. So we're going to open this up. This is going to prompt us to connect to the machine right here. There are two options. There is an offline option or an online option. If the machine is off and you just want to use the software for analysis, you can choose the offline option. That will not allow you to run anything. It'll just allow you to analyze scans that have already been run. So if you're planning on running anything, you're going to click on the MCL machine and click Connect. When this starts up, it will start up in Experiment View. It will also have open any scans that were left in kind of in the queue for running on the instrument. Most of the time you can just leave those alone unless they are in what's called the running queue, which I'll get to that in just a second. But this right here, this is the Experiment View. We have two tabs up here at the top and then a control panel. Those will almost always be showing. This first tab is called Experiment. This is where you start and stop your tests. You also can get to the Help menu here, which is pretty explanatory, very helpful if you need it. The other tab is called Instrument. This is where you can open and close the furnace. You can shut down the instrument. You can also tear samples, which we will go over how to do that in just a moment as you're setting up your experiments. The other bit over here is the control panel. Most of these things I don't pay a ton of attention to until this machine is actually running. For example, it has remaining segment time or remaining time. Because nothing's running, there is no time going on. Temperature of the room typically varies between 20 and 25 C. Depending on how many people are in here, what time of day it is, how well the fan's working, etc. What I do pay quite a bit of attention to on here are the two options called balance flow and sample flow. Both of these should show 100 milliliters per minute. That means that the nitrogen, that's what the balance flow is, so that's what's going over the instrument. That is the nitrogen there, and then the sample flow is whatever you select it to be. So that could be either nitrogen or air. But you want both of them running at 100 milliliters per minute. If it is less than that, then either your tank is empty or the tank is turned off. The machine will not allow you to run while either of those is below 100 milliliters per minute. So that's something that you want to double check before you start going into things. It won't even let you weigh your pans unless these flows are working properly. If you need to change between air and nitrogen, there are a couple ways to do it. The easiest way is on the control panel. Click on General down here at the bottom. You can see there's Auto Sampler and General. So you're going to click on General, and then right here you select whether gas 1 or gas 2 is going to be your sample flow. Balance flow, you can see there's nothing to change here. That's because the balance flow is always going to be our nitrogen gas. But you can select between the two here. You also can choose the flow rate. 100 milliliters per minute is recommended. If you have reason to believe that you should run at a different flow rate, please talk to staff. That will often require a recalibration of the instrument before you run your samples, which will delay you by about a day or two. Alright, so those two are always going to be visible, this top ribbon and the control panel. We have 4, technically, windows that can fill up the rest of our screen here. We only really use 2. You as a user will only really use 2. And I will expand this a little bit so you can see it. So the 4 options, apparently that does not expand up. The 4 options are experiments, history, results, and calibration. You're pretty much only going to interact with experiments and results. Experiment is where you're going to set up a scan. You're going to put it into the queue, which is like the line, and you're going to have the auto sampler run those scans for you in a sequence. The other window that you're going to work with is results. That's where you're going to analyze the results from a test, and we will get to that once we have some results. The history view does not work very well because of the way we save our files in the MCL. So it works, but you won't interact with it much. And then the calibration window, if you are changing to a different gas that isn't nitrogen or air, if you are changing your ramp rate to something other than 20 degrees per minute, and if you are changing your flow rates on your gases. Those are the three most common reasons you would need to change the calibration. That is something that's only done by staff. So if you have any reason to change any of those three things, the ramp rate for the temperature, the gas type that you're using, or the gas flow rate, talk to staff and we will work on calibrating for you. We're going to start in experiments here. This is where you will most likely start. There are two queues, three sort of, and a queue is just a line or a lineup where you put your scans that you want to run. You put as many as you want, and then the machine with the auto sampler will run them one after another. So the three queues, one is called the incomplete queue, that's here at the top. Those are for samples that started running but for some reason failed. Either the gas ran out partway through, or maybe there were vibrations in the table that caused the machine to cancel the test. There are a couple different reasons that you can get something in the incomplete queue, but that means that it started but didn't finish successfully. The next one is the running queue. This is where you're going to put your samples, put your experiment files, if you want them to be run right now. The last one is the design view. This is where you can create experiments, but the start button will not be enabled on the machine, so you won't be able to start them immediately. The difference between the running queue and the design view, they're pretty much the exact same. You can set up your experiment. All of the actual experiment parameters and options that you have are the same between them. The running queue, however, is like standing in line for a roller coaster. Eventually you will get to the front of the line and it will be your turn to get on the roller coaster. The design view is like standing off to the side of the line. You are standing there, you can see the roller coaster, but at no point will you get to the front of the line and will it be your turn to run. So if you have experiments down here, you have to bring them up into the running queue if you want them to be run in the machine or put on the roller coaster. You can see there are two scans here that were left here from a previous client. If you wanted to create something in the design view, you could just right click and click insert or append run. That would create a new run for you. We're going to start directly in the running queue because we want to run this right away. The main reason for the design view would be if something is running currently, there's a client from before you whose scans are finishing up, you wouldn't want to create things in the running queue, otherwise you'd be pulled into the machine as soon as their sample is done, when you might not quite be ready for that. So in that case, you put it in the design view. But most of the time, if the machine's not being actively used when you show up in the lab, you're going to start your scans in the running queue. If there are scans in the running queue and no one is scheduled to use it but you, feel free to select them, which you can do by Control and click. Right click on them and you can copy them to the design view. Since I'm in the design view, it has me copied to the running queue. But if you want to just move those to the design view, get them out of your way, and then you can just run your own samples in the running queue. If the queue is empty, you'll have these two options, create new runs or load sequence file. We're going to click create new runs, and that created a run 1 with the assumption that we're going to start on pan location 1. If you look over at the sample tray there, you can see that there are numbers, numbered 1 through 30. There will pretty much always be a pan on location number 30. That is our reference. We just leave that there. As long as it is clean, you are welcome to use it. If it is not clean, let staff know, and we will replace it with a clean reference. But number 1 is up in the top left, and then it kind of counts up sequentially from there. This first section in the running queue right here, or in the experiment setup, we are going to put in the sample information. So we've got your sample name. You're going to tell it the location of your sample pan, which one is most typically going to be your first sample, but if there are if there are crucibles on the sample tray that have been left there, you can put whatever you want. You can put 15 and have 15 be where your sample is. You just need to tell the machine where your crucibles are. And we are going to choose a reference pan. So like I said, number 30 pretty much will always have a reference on it. And that is programmed into here to know that 30 is a reference location. If you are using your own crucible type rather than using our crucibles, 28, 9, and 28 are also set up as references. So you can put your reference on number 28 or 29 instead of using our number 30. Now at this point, we're going to click Edit Tray Configuration. This is going to take us to a screen that has an image of the sample tray. You can see a lot of these are selected in yellow. There are 2 or 3 different colors that you'll see circling some of these sample tray pieces. Yellow means that internally the machine has a weight saved for that location. Typically that's going to be the weight of a crucible. However, each crucible weighs a slightly different amount, and so if there is no crucible on number 1, then the value that it has saved is invalid, because we are going to need to reweigh a new crucible. There's nothing on sample location number 1. If there is a green circle, which I will show you in just a second, that means that the machine believes it has a valid tear, where a yellow circle is an invalid tear. The reason it would invalidate a tear, which tear just means the weight of a crucible, the reason it would invalidate is because it has already run a scan using this sample, using the weight of this crucible. So it believes that there's a possibility that that crucible has been removed from the sample tray, or that it has been, the weight of the crucible has changed because it's been run. So these are all yellow. I'm actually just going to click Clear All Tears. Cool. I was kind of hoping that would happen. There are 2 or 3 things that you can do to make the software bug out. That is one of them. For some reason, clearing all the tears will just close the entire software. It will save whatever information you've put in on the experiment setup, typically. Yep, and there we go. So, pretty much saved our experiment view here. But I'm going to go back to this tear window, and now you can see there are no circles around any of these. That means that there is no weight value that has been recorded for any of these or saved for any of these. We are going to run, let's say we're going to run 2 samples on location 1 and 2, and we're going to use number 30 for the reference. At this point, we're going to tell it that we are using alumina crucibles. 1 and 2 are samples. Number 30 is a reference. You can see tear state says not teared, so we have no values saved for those. What we're going to do is we're going to grab crucibles out of the drawer, and we are going to put them onto the tray, and then we're going to tell the instrument to weigh those crucibles. So all of our consumables for the TGA are in here. Typically the stuff in here is all you're going to need to use. We've got crucibles here, tweezers, and a spatula. We are going to grab a couple of crucibles. These are just a little aluminum oxide crucibles right here. And I'm going to put 2 crucibles, making sure they're right side up, on locations number 1 and number 2. You don't want to touch these with your hand. They will absorb, they absorb water from the air, and they'll also absorb any oils on your fingers. So for the sake of making sure that they don't have anything that's going to contribute to your DSC TGA results, we're going to make sure not to touch them. And you just place them in the locations where you want them to be placed. If you notice that we have fewer than 5 crucibles left in here, please notify staff, and we will order a new set. And anytime I'm talking about notify staff, you can do that by finding someone in the lab or by emailing the lab. You're welcome to do either. Now that we have our 2 sample crucibles and our 1 reference crucible here on the sample tray, on the software, I'm going to click Tear Selected. And you will see the machine jump into action. The tweezers down at the bottom are going to just do a little startup. They just kind of stretched out, opened up. It's going to grab pan number 1. And it's going to set it on the sample beams. And it will do just a little twist on there to make sure that the sample is sitting properly in there. There are times, because this is a moving parts kind of machine, there are times when the sample cup does not sit properly. If you notice that it's not sitting properly, feel free to grab the tweezers and just set it or kind of bump it back into place. And then it will also grab the reference and place the reference on the reference beam. And again, it'll do a little twist to make sure that is sitting properly. Then the auto sampler will go back to its home position, which is kind of hovering right over the sample tray, and the furnace will close over the samples. That weird little squeaking sound is the furnace sealing up against the base. That makes sure that there's a unidirectional airflow there. Once it has stabilized, it will open the furnace back up, pull the samples back off and put them on the sample tray. Then it will grab sample number 2 and repeat the process. Because the reference location number 30 has already been saved, it will not re-tear number 30. It will only do number 2. So it's going to pull both number 1 and number 30 off of their beams. And because those beams are made out of aluminum oxide and our crucibles are also made out of aluminum oxide, there is a little bit of friction between the 2 rough surfaces. So you'll notice as it lifts up, occasionally, oh, well that was beautiful. It didn't do it this time. Occasionally it will stick somewhat, where the beam will follow the crucible up and then fall down. The machine is not strong enough to break itself. Either it will drop the crucible or the beam will drop back into place, so there is no need to stress out if it does stick a little bit. What it did just there was a beautiful example of how it should work all the time. I'm sorry it didn't do it wrong for you guys today. We'll see if the reference sticks at all. There we go. So there's sometimes just a little bit of sticking, and that's not anything to worry about. It's just because we have those 2 rough surfaces right next to each other. There's often a little bit of gravity. But like I said, it's not strong enough to break itself, so it'll either drop the crucible or drop the beam. It is important to pay attention if it does drop the crucible and there's material in there. It's important to clean that up. Do not just leave that there. Once the tear has completed, you will notice a dark green circle around each of the pans that you just teared. So 1, 2, and 30. Now, the machine does not always know to invalidate these. If I were to remove sample pan number 2 and replace it with a different crucible, then it would still consider this a valid tear with the green circle, but you would need to keep track of the fact that now we need to re-tear number 2, since each crucible does weigh a slightly different amount. However, we've got 1, 2, and 30 all set up. While the tear is running, we can go back to the running queue, click on the experiment setup that we're working on, and continue working on it. Remember, we got there by clicking Edit Tray Configuration. So we can continue working on this while the tear is running, or you could wait for the tear to complete. If you have more than 5 samples that you're going to run in a row, so you're tearing more than 2, 3, so this was 3 here. If you have more than 5 that you are tearing, I'd recommend starting the tear early in the process. It will take several minutes for the machine to go back and forth with each of the sample crucibles. So back to the experiment setup. We're going to call this name. Our first sample is going to be sample pan number 1, and I will show you how to add sample pan number 2 in a moment. We're going to tell it the reference pan is 30. We already went into edit tray configuration, and actually the reasons these were empty is because the software crashed on us a minute ago. Put in information about the operator, the project, and any notes that you want to add. So if we are running a sample for a client, typically we will put the name of the lab technician who's running it. If you have multiple people in your company or in your research group who are running the TGA, it's helpful to have operator. And then project and notes, pretty self-explanatory. The last thing we're going to do under the sample information header right here is click on the down arrow next to file name. We are going to tell it how to save the file and where to save it to. By default, it's going to name our file just after whatever name we put up here in the sample name. However, by default, it is going to save to the wrong location. So we're going to click these 3 dots right here where it says select file path, and that will open up just a file explorer. This machine is connected to our lab network. The lab network can be found under this PC and then MCL, and it'll usually say chips.eng.utah.edu. You can see it right here. If you are connected to that, you'll be able to see a list of all the instruments. If you are not connected to that, then when you click on this, it will pop up a login page. Only lab technicians and employees of the lab have login information for that. So if there is a staff who is in the lab actively right now, go ask them to log into the network for you. If there is not a staff in the lab, then you may save your information to the desktop. There is a folder called temporary user data. If you cannot find this folder, just create a folder on the desktop with your name and something that says temporary. And when we get a chance, one of the staff will move that to the actual user data. But this, here is this PC. We've got the network. Here is a list of all of our machines. This is the DSC TGA right here. Opening that up, there is a folder for manuals. There's also a folder for user data, so you can read through the manuals. Underneath user data, you will find a list of the people who have saved things here. If you already have a folder, save within that folder. If not, create a new folder to save your information. So we're going to go to my folder here, and we are going to name this training, or no, sorry. Right now what we're doing is we are selecting a folder where it will save these scans from today. I don't want them to save under my main name folder, so I'm going to actually create a new folder called training, and I'm going to save under that folder. Now this looks like a file explorer. It looks like what you'd normally open up, but remember that this popped up because we're in Trios, which means that we're a couple layers deep in accessing this. It looks like creating a new folder today may have caused it to crash. We're getting a not responding error on here. Yeah, we're gonna just close Trios and try that again. If you have issues like this, you can open an actual file explorer rather than the file explorer that opens through Trios. You can create that secondary folder there and then save to that folder. Once you have the folder selected though, you're going to click Select Folder here in the corner, and that will automatically, as the scans are collecting, save your data to that folder. So that means that if there's a power outage halfway through your sample and it only collects half of the data, it will have saved as it went, so you will have that entire half of that data without having lost all of the progress that you've made already. So I have restarted the software after that little crash, but the file name is now saved to user data and my name. Like I said, it's going to automatically try to save as sample name. You can add other tokens, such as the operator or the procedure name. So those would be things like you want to run the same sample 3 different times under 3 different procedures or 3 different temperature ranges. You could add sample name and then type an underscore and then add procedure name. And now it's going to name it by whatever my sample name is and whatever my procedure name is, which we're about to move on to procedure. So that was this first bit under the sample header. The next bit is under the procedure header. When you create a procedure, you can save it by clicking this Save button, or you can, and when you have a saved procedure, you can load a procedure. We don't have any saved procedures to load right now, so we're just going to create the procedure. There are a bunch of different options in here. These first couple, first 5 or so, are pretty self-explanatory. They are called ramp, isothermal, heat, cool, heat, stepwise isothermal, and cyclic. Those are pretty traditional. You start at a temperature and you heat up, or you heat up to a temperature and then you hold, or then you heat and then you cool down and then you heat again. With any of these that include a cooling step in it, it's worthwhile to note that we don't have any cooling mechanism on here other than just generic things cool down when they're in an environment that is colder than they are. So the furnace does eventually get back down to room temperature, however, it takes a very long time because there is no active cooling going on. So if you are interested in cooling data, just be aware that that is not going to be a linear cooling, and it may take a very long time. But ramp and isothermal are kind of the most common in here. There are 2 in here that both start with the word verify. Those are part of the calibration, and you shouldn't really ever have to mess with those yourself as a client of the lab. The next 4 are called modulated DSC and modulated TGA. Modulated is where instead of heating at a constant rate, it heats at a cycling rate. So it heats faster and slower and faster and slower. Modulated DSC is used most commonly for separating, and TGA also, is used most commonly for separating out the difference in the kinetic and the thermodynamic properties of your material. If that is something that is interesting to you, you're welcome to play around with it. By clicking on the Help menu up here, you can get more information about each of those 4 options. If you don't know what that means, or you don't care about thermodynamic versus kinetics, you can ignore those 4. The next ones are called high res, and high res is a feature specifically for TGA that TA has developed. And what it does is it's sort of like a smart heating process. So as you are heating up, if it notices there is the beginning of a weight loss, it will actually slow down its heating rate in order to capture that weight loss before it moves on to the next temperatures. This is particularly useful if you have signatures or things that are going to burn off in your sample at very similar temperatures. Maybe you have something burning off at 200 and 210 degrees Celsius. High res is going to help you separate out those two events so that they don't run over one another, so that it doesn't start burning off at 210 before whatever material at 200 is finished burning off. So those are for TGA only. If you are interested in the DSC data, which it does collect both DSC and TGA at the exact same time, No matter what, whether you're interested in the DSC and the TGA or just interested in one, it does collect both at the same time, always. Unless you're in high res, in which case that is not a DSC friendly method, that is just for TGA. Most clients will choose a ramp, which is the second option down. The first option is custom. Custom allows you to mix and match pretty much all of the options in this menu here. So you can heat up and then hold it and then heat up again. You can choose different rates of heating, etc. I'll show you ramp first. If you choose to use ramp, it gives you the options here. Your start temperature is whatever the current temperature of the machine is. If you are starting when the machine is cold, meaning nothing has run previous to now, or at least not recently, then the temperature is going to typically be between 20 and 25 degrees Celsius. If you choose your start temperature as current and you are working on a sequential run, that's to say, like my pan number 2, where it will be run after pan number 1, then your start temperature will typically be around 50 degrees Celsius. Since cooling from 50 to 20 takes a very, very long time, it will typically call 50 degrees Celsius to be close enough to room temperature for counting. Our heating rate, we are calibrated to 20 degrees Celsius per minute. However, you can change that. If you are concerned about calibrations or extremely accurate data, I would recommend changing. I would recommend talking to staff to get a new calibration before changing your heating rate from 20. And then you put in your final temperature. Our final temperature is 1500 C. That's the highest that our furnace can go. However, as is the case with all furnaces, the longer you spend at the highest temperature, the shorter lifespan you have on the furnace itself. So if you do not need to go up to 1500 degrees Celsius, please do not. Even 1450 or 1400 can make a pretty big difference in the lifetime of our furnace. But you can change that to be whatever. So we could say we only want to go up to 200 degrees Celsius. We can, at some point, switch to gas 2. Gas 2 being air, in this case. So we could heat up to 100 degrees Celsius in nitrogen, and then switch to air at 100 degrees Celsius. We can also opt into a final isotherm, where it holds at the top temperature of 200 degrees for a certain length of time that is described in minutes. So you can see this is just a template for a typical ramp, and we have quite a few options already for just a really simple program. If we want to do a custom, this is how it will typically open up. What it did is when I opened up custom, it brought over all of the segments that I had put in using the ramp template. But we've got this list of segments here, and you can click and drag them over. So here is a ramp. I'm going to drag that over. You type in your heating rate and your final temperature. So this is just like before. We're ramping 20 degrees per minute up to 200 degrees Celsius. You can choose an isotherm. You can choose select gas. So that's where you can select between gas 1 and gas 2. Gas 1 being nitrogen, gas 2 being air. You can also select whether you're using high resolution, which is the high res options that I talked about earlier for TGA, and all sorts of things like this. So you can click and drag and kind of create whatever you want. So you can ramp up to a temperature and then hold it, and then ramp to another temperature and then hold there. And you can do that as many times as you want. These can get pretty complicated, although it is still fairly simple to set up. Once you have a custom test that you like, and as a note, you do not have to put in a cooling step at the end of this. It will cool automatically once your test finishes. Click apply, and now you can see we've got these nice 2 steps. We could save this procedure. We could also give this procedure a name. so that in the future, all of the effort you've put into creating this custom test can be loaded quickly, and it takes maybe a second or two. Once you are happy with the procedure setup, under here underneath Advanced, most of these you will not have to change, but I'll explain them to you. This first bit is beginning of test. It will start the experiment after weight stabilization. That means that if there is for some reason, vibration on the table or the weight of your sample is changing quickly, it will not start the experiment until the weight has stabilized. Most commonly, this is to keep there from being any vibrations on this table. This is a table that is internal to our lab, meaning that all of the walls on it are connected to internal lab things. And there are no vibration causing instruments, at least not significantly, connected to this wall in our lab. So that's pretty uncommon to get any vibrations. An interesting application of this is if you have an alcohol that evaporates quickly in your sample. Usually those are very pungent smelling alcohols. If you have something that's evaporating quickly during your test, the weight will never stabilize because that alcohol is continuously evaporating and you're continuously losing weight. So that's one interesting application of that where you might want to turn that off. Typically we leave it on though. End of test is air cool. That means it will allow air into the machine starting around 1,000 degrees Celsius until the temperature is at just below 50 degrees Celsius, and then it will end the test. If your sample is particularly sensitive to air, especially at high temperatures, you would not want to enable air cool. The last one is selected calibrations. Typically you can just use default calibrations, especially if you're running in nitrogen. If you are running in anything other than nitrogen, if you're running in air, for example, or you have coordinated with the staff to get a calibration run specifically for you, this drop-down menu will have your calibration in there. Typically, you will not need to do that. Most people will run in nitrogen, but if you need to change to a different calibration, that's here. The last bit is analysis and reporting. If you have a report template or an analysis template that you want it to automatically apply to your data, you are welcome to do that. This is a brand new feature and we're not used to using it here in the MCL. You're welcome to play around with it if you would like, but it's not very common for us to use that. Now we have a completely set up experiment here. Our run in the running queue is nice and in place, and you can see that the start button is active. That means that according to the software, we have everything that we need to start the scan. Before we start the scan, I am going to create my second run because we have 2 pans on the sample card. I'm going to do that by right-clicking on the run that I just made, and I'm going to click Append Run. What that's going to do is that's going to copy all of the data from pan 1, and it's going to apply that to pan location number 2. The other option is to do Insert Run, which is going to copy all of the data from pan 1 and create a second identical run. So you can see when I clicked Insert, it gave us 2 pan 1 options. They both have the same procedure information. When I clicked Append, it gave me the same procedure information, but applied it to pan location number 2 instead of number 1. So I'm going to right click on one of these, I'm going to delete one of those runs. So I've got pan 1, pan 2. You will want to change the name. So name, oops, and I'm going to put like a 2 in parentheses there, name 2. Sample pan location, reference pan location, and procedure. You just want to kind of double check that all of this looks good. But now I have pan 1 and pan 2 both created with the experiments. If you don't want to create the same experiment for pan number 2, or you don't want to use the same procedure, you're welcome to come down here, click Edit, delete both of these segments, and create your own procedure, or run one of these templates. Once you have these in place, we are going to load the sample into your crucibles. To load the sample in your pan, and you want to make sure that you do this before you click Start on the instrument, We're going to grab the pan and place it here on a kim wipe. Most commonly, people will run powders in the TGA. Sometimes people will run liquids, and sometimes they will run pellets or small solid pieces. No matter what you are running, you want to aim for about 10 milligrams of material. If you have a very low density material, something very fluffy, such as fibers, you may not be able to fit 10 milligrams in here. If that is the case, at most, you only want to fill to halfway up the crucible. You do not want to overfill the crucible. There is airflow inside of the furnace, and especially with fibrous samples, it's common for those fibers to get caught by the airflow and to fall off or fall out of the crucible. So by only filling to halfway, we avoid that. Avoid burning material on the inside of our furnace, keeping our furnace nice and clean. If you have a solid sample here, you want to try, especially if you are interested in DSC results, you want to try to find a flat surface and place the flat surface down so that it's sitting flat on the base of the crucible. That's going to allow for good heat transfer between the detectors on the bottom of the sample beams and your sample, leading to more accurate DSC results. If you have a powder, same thing as with the fibers, you want to make sure that you're only filling to halfway, and that's actually also true for liquids. Do not fill more than halfway. If you have a solid and it is too large to fit in the crucible, please cut it down. We don't want anything hanging out over the edge of our crucible, again, because that can cause the machine to get contaminated with whatever your sample material is. If you're not sure how much 10 milligrams is, don't worry about it. It's not the biggest deal. The TGA will measure how much material is in there to start with, because, as you may remember, it knows the zero weight of this crucible. So when we put this back onto the sample beam, it will weigh the difference between what it weighed before and what it weighs now, and it will know how much your sample weighs. But aiming toward 10 milligrams is going to mitigate any really big kinetic issues that you might have. For example, a gigantic ice cube is going to take quite a bit more energy to melt than an ice chip. So if our sample is too large here, then you're going to see delays in the events on your results. Typically, for most samples, 10 milligrams is just about enough to cover the bottom of the crucible. So if you've got a powder or fibers or a liquid, you typically want to just have just enough to create sort of a little layer on the bottom of the crucible. Again, if you have something that is less dense, you might need a little bit more than that, but never overfill. You want to fill only one crucible at a time because all of the crucibles look identical, and it would be very easy for me to mix up crucible number 1 and crucible number 2, which the software would not recognize, but that would invalidate the tears that we did earlier. So I just pulled off number 1, I filled it with my sample number 1, and then I'm going to put it back onto the sample card, at which point I can repeat the same with sample number 2. Pull sample number 2 off, fill it with sample number 2, and put it back on. Only fill one crucible at a time. Once the sample has been loaded into the crucibles and your experiment is set up, you are free to click Start. That will automatically start the machine to grab your samples. It will grab whichever one is first. So in my case, it will grab pan number 1 with its reference, and it will start the test. once the furnace is all the way closed, you will quickly start to see the temperature start rising. You may remember that we are calibrated to 20 degrees per minute. So this test only going up to 200 degrees Celsius is only going to take about 10 minutes to go up. To cool down from 200 degrees Celsius will probably take about half of an hour. So you do want to take that into account while you are planning for the amount of time that you'll have in the lab on the machine. But if you look on the screen here, we will start to see this rising slowly at first, and it will start to pick up speed until we get to about 20 degrees per minute. You will also see on the screen, it has changed our view. So originally we were in experiments view down here in the bottom left corner. It has jumped us immediately to results view, and it is showing live time the results from inside the DSC TGA. The first several degrees, there's a lot going on. There's something called the Buoyancy Effects, which means that we have a lot of air that is just trying to establish its flow, so there's a little bit of turbulence in there. We also flicked on the furnace, which caused quite a few electrical signals to go back and forth through our electronics. So for that reason, the information between 20 degrees and about 50 degrees, you'll see quite a bit of fluctuation. So you can see this blue line right here is our heat flow line, so this is our DSC line. Normally a DSC background is nice and flat, but we do have sort of a curve going on here, and it is decreasing currently. That is due to both the buoyancy effect and the electronics just being turned on. So I typically don't look at anything lower than 50 degrees Celsius. If you are interested in temperature events that are happening below 50 degrees Celsius, we do have a low temperature DSC that goes down to negative 150 degrees Celsius that I would recommend using in the regions around room temperature. These other two lines, the green and the red, are for weight in percentage and weight in milligrams. You can see we haven't really had much weight change so far. We're sticking around 100, and it looks like my little pellet sample was about 21.5 milligrams. So quite a bit bigger than the recommended 10 milligrams. If that's something that is causing issues in your experiments, you are welcome to cut down your samples to get them a little bit smaller. So I could have cut mine in half in order to get it to fit a little bit better within the recommended weight. However, if you are not interested in, if you're not too worried about a slight delay in the readings on your temperatures, then it doesn't matter if you have more mass. Up here in the top corner, it's going to show us what our current temperature is. It's going to show us what segment we're on, which is ramp to 200 degrees Celsius. It's going to tell us how much longer on that particular segment. I have two different segments on mine. I have a ramp to 200, and then I have an isotherm for 1 minute, so it'll hold at 200 for a minute. So this value here does not have the entire time that it will take to run my experiment. It only has the time that it's going to take to run this particular segment of my experiment. The other two segments is isotherm, and then after that is a cooling segment that it does not list, but is on there. You can keep an eye on all of the controls here, the temperature, the remaining time as it has its guess, the weight change that has happened so far, temperature differences, heat flow, etc. So you can see all those values here in the control panel. Once this finishes running, we are good to export or analyze the data as we see fit. We are now in post-test mode, so it has been the 11 or so minutes that was necessary for this particular test. You can see that our lines have changed color. When you have more than one segment, like we did where we had a ramp and an isotherm, what it will start to do is change color by segment. So you can see these are green here and these are blue, rather than changing color based on the y-axis that it corresponds to. I personally find that a little bit difficult to work with, I prefer to have colors correspond to the y-axis, and I'll show you how to change that. We are in the results pane, meaning that we can do some analysis on this. Analysis will include anything from on the DSC line, figuring out onset and offset of curves, or area under the curve. So this is actually our DSC line here, and you can see we had an event occur here at about the same time that we started losing mass, so probably those are related events. So we can figure out area under the curve, etc. And then with the weight change, you can see we started at 100 and we ended at about 99.4 or 5. Unfortunately, I don't know which of these lines is the weight percent and which one is the weight in milligrams. I believe this lower one is the one that is weight percent, since it seems to start at 100, although I might be mistaken. But you can see we ended about here. This is a pretty tiny weight change, but we are precise down to a couple hundredths of a milligram. So seeing this weight change in here from, 0.46 to 0.38, that is within our limits of accuracy. So we did probably lose some mass, possibly a little bit of melting occurred and a little bit of burn off at the same time. At this point, if you just want the raw data rather than dealing with all of the analysis, which I will go into analysis in just a moment, if you want just to export the data, you can go up here to the bubble in the top left corner. There is Save As. You can save it as a Trios file format, which it saves that automatically, or you can save as a PDF. The nice thing about saving as a Trios file format is Trios is actually a free software that you can get by going online. Just Google or type in your search box TA Instruments Software Download. That is TA space Instruments Software Download. And you can find Trios as well as pretty much all of their other software for free. So that's nice. If you save it as a Trios file format, you could go home and do analysis on your own rather than staying here in the lab. That's a lot more comfortable. The other options are to go here to export. You can export a text or a CSV file. CSV files are really easily read in Excel. There is also an option to launch directly to Excel. If you have a test that is longer than 3 hours before cooldown, there is a high likelihood that the export to Excel will fail. In which case, I export to a CSV that opens really nicely in Excel, and you don't have any issues there. You can also export the image or the parameters that you used for your file. So that is under this bubble up in the top left corner. You also can review what happened. So down here on the bottom, we've got 3 tabs. This first one is called Step Overlay. So that's our graph. The next one to the left is a table. These are all of the results that we got, if it'll let me scroll, there we go. And you can see time, temperature, heat flow, weight change, and we've got another heat flow. This first heat flow is a normalized heat flow, where it is watts per gram, and that is heat flow normalized to the weight as it changes. The other one is just a raw heat flow data. The normalized heat flow is the most common result. So we've got this, and the next tab over is Run. So you can see this looks just like the experiment setup. We've got the sample name, sample pan location, and the procedure information. This is really helpful for going back if you want to see what procedure you ran previously. You can open up your files and see here. Under both the isotherm and the step overlay, let's say you want to export this information to a CSV, but you want more information than just is here, or maybe you don't need all of these columns. You only want weight percent and not weight in milligrams. If you right click on here, there is a button called Select Variables. This will allow you to choose the variables. So these are the available variables on the left side. On the right side are the displayed variables. So let's say you don't want weight in milligrams. You click on it, you tell it to go over to the other side, and now it is no longer here. And if we look here, now we just have weight percent, although weight in milligrams is now at the end. So I don't know why that didn't stick. Be gone. Well, it is not interested. Possibly the reason it is not updating is because this is still technically an active test. You can see we are in post-test and it is cooling down right now. You can tell that this is still active because up in this top tab we have a green circle. The green circle indicates that this is still active. A lot of the analysis options are not available when you are actively running the scan. So it's very possible that it's not letting me change that because we're still in an active scan. If you want to open up results in here, we've got these options over here on the left side. This pane will have all of the sample scans that you have open. They will be open in tabs along the top, and then you can open them. You can do some other things with them. You can do batch analysis, etc. So that's all of this up along here. So I have opened up a new file. You can see that this is a new file. This is the file that we ran just a moment ago. It is still active. It's still in its cool down process. So we've still got the green dot. This kind of square looking symbol here, that indicates that this is a completed file, meaning we can do some analysis on it without risking crashing the software or panicking the software at all. So this is literally Jello that a lab class ran several years ago. If we go over to the run information on this bottom set of tabs, we can see that they had two different steps. One was a ramp up to 120C, and then they held it for 10 minutes. So this is actually pretty similar to the scan that we just barely ran. This was them heating up in the blue here, and then you can see the rest of this, that's their isotherm. So what's going on right now is the color delineations are showing the differences in the steps, so between the blue and the green. And it's a very, very subtle difference, unfortunately, but these are technically different line styles. This is a lighter, kind of thinner dotted line, where this is more of a thicker dashed line. That is currently what's showing us the difference between the y-axes. So our heat flow, this line is a solid line. This is supposedly a dotted line, which refers to our weight in milligrams. And this is supposedly a dashed line, which refers to our weight percent. This is very difficult to see, and I very much prefer color. However, you can change it however you'd like. In order to change how things are delineated, we're going to right-click on here, and we are going to go down to Curves Format. This is how we're going to be able to format the actual lines on the graph. We can increment by variable, so that would be our y-axis, by step, which would be like the ramp and the isotherm, or by file. It is pretty easy to create overlays where you put several files on top of each other, and you can create them, you can give them different delineations between each file so that you can tell which one is which. Automatically, it's going to select based on the number of steps or the number of files, the number of variables that you have. It will automatically select these. However, we can change them ourselves. So for me, I typically don't care about different steps being separated in the image of the graph, but you can see by step we can change the color, which is what we're currently selected to with the blue and the green. You can also choose symbol, which symbol gives you these options of symbols right here. We also can choose line style, which that is currently what the variable option is using, so that's line style there. And then extra symbol, so that would be different symbols than are available in the regular symbol option. I'm going to click none because to me the steps don't matter. To me it's really the data over the course of time here. And then under variable, I'm going to choose color because like I said, I prefer color. So you can choose which colors. It's going to start this is the first color that will be selected, and then second and third. If you're looking for a color palette that's specific, you can select colors that kind of look similar but aren't the same. But these are the defaults here, where the first line will be considered blue, and then green, and then red. So I'm going to click OK, and then OK, and you'll see that changes our graph. So blue, and then green, and then red, those were the first three colors, so it automatically applied those to these lines. Blue is to heat flow, red is to weight in milligrams, and green is to weight percent. I often also find it redundant to have weight in milligrams and weight percent shown on the same graph. Sometimes it's not, but if you wish to change that, we're going to right click again and click Select Variables. We have up to 4 y-axes. You can see 1, 2, 3, and 4, and 1 x-axis. So our left y-axis here is currently heat flow. I'm going to keep that. That's going to be the DSC data. Y2 is weight percent. I'm going to keep that as well. Y4, the other one on the right side, is weight in milligrams. I'm going to deselect that because I just want to see weight percent for now. On our x-axis, we currently have time, comma, temperature. That means that the main driving variable along the x-axis is time. That's the linear one, 0, 2, 4, 6, 8, that's in minutes. And then you can see the temperature is also notated along the upper bit, but that is not linear. You can see 90 occurs here, 80 is here, but 100 is all the way over here. So that's just saying that at about 4 minutes, we hit about 80 degrees. Around 10 minutes, just a little past 10 minutes, we hit 110. So 10 and a half minutes, we hit 110 degrees. For something that has an isotherm, typically you want the x-axis to be in time rather than in temperature. If you have it in temperature, then everything will kind of stack on top of each other. It won't look like a nice function. It will, you'll sometimes get loop-de-loops and that sort of thing. So time, comma, temperature is helpful. We also could select just time if we wanted the x-axis to just be time. That would not show these temperature demarcations, but we can demarc temperature in other methods on the screen. So I'm going to click OK. You can see that cleans it up quite nicely to have just time along the x-axis, to not have the double y-axis on the same side here. So we've got weight and heat flow on our screen. You will notice up at the top there are some changes. This top ribbon, we had experiment and instrument previously. Now we have 4 more options: format, edit, analysis, and tools. Under format, we've got some buttons where you can change the zoom. You can also create reports and save analysis files. That, like I showed you at the beginning, under experiments, when you have an experiment pane, down at the very bottom there's an option for analysis and reporting. Under this format tab, this would be reports and analysis. You can create defaults of those if your group or your company prefers to see things in the same manner. The next one is edit. That's where we're going to be able to write on the screen. We can also draw certain things. So we can draw arrows pointing to this line right here. And then you could type something explaining why you're pointing to that location. So that's under edit. Next is analysis, which we'll get into analysis in just a second. You can see a lot of these are grayed out. We'll get into that in a second. And then there's tools right here. Under tools, because we have 2 different segments to our results, we have this option that says ignore breaks in data. We do have a break in our data that occurs when we reach this the 120 degrees and we change from our ramp to our isotherm. That is considered a break in the data. If we want to consider it one smooth function rather than 2 different steps, we're going to click ignore breaks in data. And while visually that will not update what we're seeing here, that will allow us to work as if this was a smooth piece rather than 2 separate steps. Now, if we go back to analysis, you'll notice that this Analyze button is active, and we're able to do all of the analysis kind of things that you would expect with a DSC or a TGA result. Most commonly with a DSC result, that's this blue line here, you're going to look for onset or offset or area under the curve. So onset would be about here, offset being somewhere over here, and then area under the curve being whatever is underneath this. Let's say we're going for area under the curve. I am going to select, click and drag on the line itself from the start to the finish. So we've got sort of a straight-ish line that goes between those two that defines my peak fairly well. And under the Analysis tab, I can click on this drop-down menu, or I can right-click on a white space and I can click Analyze. And you can see there is a whole bunch of options right here. We're going to do peak integration, which would be area under the curve. And you can see it's drawn this nice line for us. At this point, I can change where my endpoints are if I prefer to have them a little bit flatter. Once I'm happy, I can click Accept, or I can click Show Parameters for more options. Under Show Parameters, we can change the location of our cursors. We can change how it is identifying the area under the curve. We can change the appearance of these cursors in this line. We can change what information is labeled. Currently, we have a couple of things selected here. And you can select any number of things, so you can tell it what baseline type you're using. We could ask it to tell us the onset, which we can see actually it is telling us the onset. And then pass-fail, you can put in parameters to either pass or fail it if you were doing some sort of quality assurance. Once you have all of these set, you can click Accept. And you can see we've got our enthalpy in joules per gram. Our onset is at about 2 minutes. You'll notice that this is in minutes rather than in temperature because our x-axis is in minutes. There are ways to change that though. So if we right-click on here and click Edit Analysis, so I right-clicked just on the text box here, we can change these again. So this would be a label issue. The onset, actually I think since we don't have temperature, it will not, oh there we go. Onset temperature right here. So we can tell it to add the onset temperature instead of just the onset X. 48 degrees approximately where our jello began its endothermic reaction here. It also gave us the peak temperature right here. If you are interested in doing just one of those things, so let's say we only wanted the peak temperature, then I would select, again, click and drag over the area of interest, right-click, click Analyze, and I could say peak information or any of these other analysis options. Feel free to play around with it. If you don't like it, you can click Delete to get rid of the analysis that you just ran. So we can click Delete, and that will get rid of the analysis that we just ran. On the weight change, most commonly the kind of analysis that you're going to do is the change of weight over a certain area. So we're going to say kind of from start to finish, we're going to select this whole S-curve, right-click, click Analyze. You'll notice because this isn't a DSC curve, we can't do the enthalpy of the curve. However, we can choose weight change over the range, weight loss or weight at the time or temperature. There's also residue, which would be the amount of material left right here at the end compared to at the beginning. So with all of these, you can analyze them. They all have different options depending on whether you're looking at a TGA curve or a DSC curve. And you can use that information together to identify your events. Once you're happy with all of the results that you've done, so We'll just do a quick weight change here, except so we lost approximately 78.7% of our mass of jello between these two temperatures. And again, if I right click and click edit analysis, I could tell it to include the labels starting weight and ending weight. So we started at this weight, ended at this weight. We could also tell it to do the starting temperature and the ending temperature rather than the weights if we wanted to see, between what ranges of temperature we lost this amount. But once you're happy with how this all looks, then we're going to click on the bubble, click export, and exporting the image is going to give you all of that data. You also can write it down on your own in your own lab notebook. There are a lot more options on this software, and you are welcome to play around with them, or also to use under experiment, use the help menu to learn a little bit more about what kind of analysis options are available to you. These are a couple of the most common, but this is a very powerful analysis software as far as it goes. There are a lot of options, and you're welcome to play around with them as you wish. As a reminder, this is a free software that you can get online, so you can do the analysis at home without having to reserve machine time to do that analysis. However, sometimes it's nice to just do a quick analysis before you send the data to yourself. Make sure to save all of your results to the network. Again, this PC, the network, the machine, and user data. Make sure to save all of your data there and then send it to yourself properly once you have all of the information that you need. Once your samples are done and they have all been returned, both the sample and the reference have been returned to the sample tray, and the tweezers, these little auto sampler fingers, have returned back to their home position, you are welcome to take your sample off of the sample tray and dispose of it. If you have a liquid or even a solid that has burned off completely, which you should see that in the results where you've gone all the way down to zero, for example, alcohols or a lot of polymers will burn off completely as well. If your sample has been burned off completely, you are welcome to return the pan to the container in the drawer beneath the TGA. Cleaning for these pans is done just by heating up the sample until the sample burns off. So if that applies to you, feel free to stick your pan back into one of the containers. If there's any residue or any discoloration of any sort on your pan, please throw it away or dispose of it properly according to whatever materials you put in the crucible. If you are in need of a Ziploc bag or a container to carry your crucibles to your own lab, talk to the lab staff. You also can, fold them up in a Kim wipe and take them home with you. That works as well. But please make sure that you do not leave any crucibles on the sample card except for the reference number 30, which stays put for all users. But please make sure that you clean all of your pans up. It is possible that you will come in and find pans on the sample card. Please do not interfere with those. Those are typically long-running projects that we have with external clients that are being run by the lab staff. Please leave those there as they, we're keeping track of those. We know that they're there. But just make sure that you clean up after yourself, and these crucibles are 100% disposable if your sample is as well.
As a reminder, push your chairs back under the desk, throw away all used Kim wipes and gloves, and take your samples with you as you leave. Please also remember to not use any personal USB sticks in the lab computers. To save your results, if the computer is connected to the internet, open Google Chrome, go to gmail.com, and email the results to yourself using the lab account. If the lab account is logged out, please ask staff to log you in. If no staff are present, a personal account may be used. Please do not log out of the lab account. If the computer is not connected to the internet, find an MCL-owned USB, usually a metallic blue color. Copy your data from the computer onto the USB. Then use any internet-connected computer in the lab to email the data to yourself. Please do not put the MCL USBs into your personal computer. Once you have completed this training video, email lab staff at characterization.uofu@gmail.com to schedule a 1-hour follow-up training session called an observation. Bring your sample to the MCL at the scheduled time, and staff will watch and assist as needed for the first hour of your machine use. After you have successfully completed the observation hour, you are authorized to schedule time on this machine in the MCL for independent use.